if I remember right, correct me if I'm wrong, but last time we had a couple minutes at the end of class for us to kind of read this over and start to get it set up. So if I remember right, you guys recognized last time that this was a water tank style question where you've got a rate of something causing the quantity to increase and a rate of something causing the quantity to decrease. And bless you. So I believe we set it up like this. J of t minus 7 as far as our net rate. And is that right about where we ended, right? Can I bring up something that Ben asked about last time that I think is probably good for the group? At the very end of class last time, we're getting ready to go, and Ben says something to the effect of, why don't we do that? Why don't we have j of t minus 7 times t? Can you guys identify with why he would ask that?
It says people per minute.
Say again?
It says people per minute, but that's also just making the rate.
It does come down to units, doesn't it? And really what the definition of it is. But I would say, aren't you guys kind of conditioned from like Algebra 1 on, whenever you see a rate, especially a constant rate like that, you're supposed to go times time? I mean, think back to Algebra 1. Didn't you do a bunch of like distance equals rate times time style questions? Or maybe like amount equals rate times time? Like if you see 4 ice cream cones per minute, you're supposed to just go times t. Right? So you're conditioned for that. So I get that. What Johnny brought up is pretty valid, though, because if you think about the units, j of t is in people per minute, and it's, of course, mentioned up there that that's a rate. And 7, also a rate in people per minute. So if I were to multiply 7 people per minute times t, what would be the overall units of 7t? It would just be people, right? Because the minutes would cancel out. And so in a case like that, you'd be going a rate minus an amount, which really doesn't make a whole lot of sense, especially in the context of what we're trying to do here. So resist the temptation to just automatically multiply by t. There could be situations where that's exactly what you do. But not in this one because we are looking to get a net rate. Okay, so let me ask you guys a couple questions here. If that is the net rate of people that are in the... Yes, sir?
Would you multiply by t to make it a rate if it wasn't already a rate?
Well, it would depend on what it is. If for some reason they gave us information, they said that the rate of people entering the concert was 7 people per minute, then yes, you definitely would. It would just really depend on the context. And it's that terrifying thought of, and I don't know that seems a little convoluted to just like try to get you to jump through a hoop. However, it's like that terrifying thought of, I'm going to have to read this for meaning. I can't just be like, oh, let me just throw a couple numbers in here regardless of context. You might have to read for meaning. So yeah, I agree. That could be a thing. All right, so that is the net rate, j of t minus 7. And we are asked to find when is the line shortest. So when you read that phrase right there, when is the line shortest? What does that sound like to you? Minimum, right? Minimize the length of the line. So I agree with you there. So I'm going to just say this really means minimization. Okay, I agree. So if we are going to be trying to minimize the length of the line, where are we going to get our candidates, or what are our candidates for this? Critical numbers, right. So critical numbers would be places where the rate of people in the line, whatever that is 0 or perhaps does not exist, right? Okay, so do we have that? Do we have the rate of change of the length of the line? Isn't that our net rate? J of t is causing the line to get longer. 7 is causing the line to get shorter. So j of t minus 7 would be the net rate of the line's length. Okay, so let's consider the DNE though first, because we will set this equal to 0 in a second. But let's consider DNE. Is there any value of t in our domain that would cause this whole rate of change to be DNE? So yeah, if we started doing negative t values, then yes, I agree with you. But notice our domain is bigger than or equal to 0. So I don't think we'll run into that based on that domain. So I don't think we can consider DNE realistically with this. But we could consider 0. So I'm going to just go equals 0. Please keep in mind, it's very important that if you are going to consider where something, in this case a rate, equals 0, you want to write that down. Don't just assume that I know or anybody knows that you're setting something equal to 0. Just go equals 0 real quick. And in a case like this, I would say the calculator is for sure active. So please take a second, use your calculator. Let's figure out exactly where this j of t minus 7 does equal 0. Okay, so check it out real quick. I don't remember what the answer to this is, but I'm sure you all can figure it out pretty quick. What did you guys get for t on this? So 2.115? 32. Okay. 32.115. Okay, so let's keep in mind what that is. That is a critical number. That's a place where the net rate is 0. Did you guys find any other critical numbers? Just that one? Okay, that's the only spot where j of t minus 7 is 0. And so that's the only one we have to test out, the only one we really have to consider. So let me ask you guys this. At this point, you've got a critical number, and at this point, you have a choice, because we're supposed to find when the line is the shortest, and all we know is that that's a critical number. We don't know that that's when the line is shortest. It could be that that's when the line is the longest, and either I wrote a bad question or we need to think about something else. So we need to justify our answer to say that, yeah, this is when the line is the shortest. So here's our choice. We have two tools in the toolbox to determine whether this is a max or a min place. What are they? What are those two tools? First or second derivative test. And this is where you get to have an opinion on something. I do too. Do you think it would be easier for us to do the first derivative test, or do you think it would be easier to do the second derivative test? Why first? Yeah, at this point we don't really know how to find the derivative of a natural log, so that's one roadblock. Later on you will. It's not that hard to do. What else would be, what would be a positive reason for using the first derivative test? Well, how would the first derivative test be easier? Yeah, we can plug stuff back in, but what do you have right now? Probably right in front of you. A graph of what? Of the first derivative. You got a graph right there on your calculator, don't you? That's how you found your 0. So what you can do now, I know the calculator is active, and so you can simply look at that graph and say, what's the behavior of j of t minus 7? It goes from what? Negative to positive. So again, I know you've got the calculator, I know you've got a graph right in front of you, so you can say something like this. J of t minus 7 changes from negative to positive at t equals 32.115. Therefore, the line is shortest then. And you're done. That make sense? So use the graph, use the calculator to your advantage. Don't be shy about doing that. So what are the elements you got to have? I've basically got the 3 elements right up there in front of you. These would be the things. You could obviously have some more as long as it's correct, but these would be the 3 elements you'd want to have. You'd want to have a net rate set equal to 0, and you'd have your critical number candidate, and then you'd have a concluding statement where you observe the sign change in the rate and a conclusion saying that, yep, this is when the line is at a minimum.
Could you label the functions like p prime of t
Sure.
j of t minus 7?
Absolutely. So let's talk about that. So if you wanted to do that, sometimes that makes the notation a little bit easier. So if you said p prime equals j of t minus 7, then instead of this, you would just put p prime, and that would fix it, right? That'd make it a little bit shorter. We've obviously done it that way before. You feel free to do that if that helps you kind of get things organized. No problem at all. Yeah. Yes, ma'am.
Do you want us to consider the endpoints, like for this one it isn't?
Great question. So let's talk about that. I was wondering if somebody would ask about that. Wonderful question. We do kind of have an endpoint, right? Greater than or equal to 0. So I'd say 0 is kind of an endpoint, but we don't really have an upper endpoint, do we? It's not like the lines, we stop paying attention at like 30, well, I guess it'd have to be more than 30 minutes, maybe like 60 minutes or something like that. If that were the case, it's certainly possible. Let's talk about the 0 here in a second. And let me say this, that later on, once we get into chapter 4, we won't, but we could revisit this exact question, and I could put a closed interval on it. And I could say, okay, so from t equals 0 to t equals 60, I don't know, when is the line the longest or shortest or whatever? Because I gave you rates, you'd actually have to use what we're going to be studying in next chapter, the integral, the definite integral, to be able to analyze the amounts if you're given a rate. So I really couldn't ask you about a definite or an absolute maximum here without knowing how to do a definite integral. But we could look at the zero. Let's talk about the zero really quick. Look at your graph real quick. When t is 0, isn't j of t minus 7 already below the x-axis?
Yeah.
Right, it's below the x-axis, and then it starts to increase up there towards that t equals 32.115 x-intercept, right? So what we could say then, we could say that from t equals 0 to t equals 32.115, I'll tell you what, let me draw a picture of this. So this would be a graph of what you guys have. I mean, essentially, doesn't it look like this? Right? So Catherine, check this out. From t equals 0 up to t equals 32.115, wouldn't it be fair to say on this whole interval, the net rate is negative? So that means from t equals 0 to t equals 32.115, the line is decreasing in length. Make sense? So that means when t is 0, there were more people in line than there were when t is 32.115, right? And so when we started thinking about endpoints, you could kind of consider 0 as an endpoint, right? Because it does say greater than or equal to 0. But if you look at the graph and you realize, all right, well, from t equals 0 to t equals 32.115, the line only got shorter. So you kind of could sort of consider it, but we really don't need to here. I would say we definitely want to consider endpoints when I give you a closed interval from, like say 0 to 60. You really would have to consider both. But in a case like this, seeing that there's only one critical number, we can probably draw our conclusion simply based on that. Okay, good questions. Anybody else? All right, awesome. So let's go ahead and move on to example number 2. I think in example number 2, you're going to be very pleased, right? Because it is another water tank question. In fact, this is the exact same water tank question that we did before, except the question itself is a little bit different. Does this look familiar? I hope it does. Kinda? Yeah? Okay. All right, so this says the amount of water in a storage tank in gallons is modeled by a continuous function. Doesn't say anything really about that continuous function, just says that there is a function. It's on the time interval 0 to 7. T is measured in hours. In this model, rates are given as follows. You got f of t is the rate at which water is entering the tank. G of t is the rate at which water is leaving the tank. G of t, again, is a piecewise. You can see the graph down below. And then the question says, this is really important. This would actually kind of go to Catherine's question about the whole endpoint thing. Notice I was very careful with the question. It says for the open interval 0 to 7. So I am not giving you any endpoints. Okay, so we don't have to consider absolute extrema here. So the open interval 0 to 7, at what time t in the is the water in the tank the greatest, and we're supposed to justify our answer. So we kind of laid the groundwork for this already because we did this setup before, but we didn't ask this question. So let's ask ourselves this question. We got this continuous function that models the amount of water in the tank. We don't know what that continuous function is. Before, I think we gave this function a name, didn't we?
Yeah.
So let's do that again this time. I think maybe we called it A of t for amount of water. A for amount, something like that. So we're going to say that A of t is the amount of water. So we are trying to find the time when the amount of water is greatest. So when you see the word greatest, what does that make you think of? Maximum, yeah. So we're going to find when the amount of water is maximized. So if I'm trying to maximize A of t, where am I going to get my candidates for me to even check? Critical points, right? Critical points would be, so critical points of A would be where A prime is 0 or doesn't exist. So first thing we got to do is figure out what A prime is. And perhaps you remember this, or perhaps you have a better understanding of this now. What do you think A prime would have to be? It would have to be f of t minus g of t in that order, right? That would change everything if it was a different order. Zach, why did you pick f minus g instead of g minus f? The word enter is important, right? And G of t, the important word is
Leave the tank.
leaves the tank. Exactly. That's exactly right. So F minus G, makes sense? Okay. So let's get our candidates from this. Never neglect D and E, right? Is there any place where A prime doesn't exist? Yes, there is. Where is it? 3, right? Double open right there on 3. So if G of t doesn't exist, which it doesn't at 3, then A prime doesn't either. So I'd say my first candidate is going to be t equals 3. And then do you see any other candidates based on now A prime equaling 0? Are there any, so t equals 3, that's where A prime doesn't exist. But what about where A prime is 0? Say again? There's 2, right? So right there and right there, the intersection points. Take a minute, either look back in your notes or use your calculator if you need the practice, whatever. But we found these before, didn't we? So this would be back in 3, I think, when we did this the first time. So let's find those 2 intersection points. That would be where A prime is 0. Is your calculator bailing on you? Had enough. Enough of you pushing my buttons. I'm out of here. Phone too? Man. Electronics. Okay. Obviously the first one's like roughly 1.6 or something like that. What is that? Just give me 3 decimals on that first one. 1 point something? 617? Okay. So 1.617, that is also a critical number. The other one's got to be like 5 something? 5.076. Okay. Okay. All right, so here is where here's where we can start to draw a conclusion. And I don't know if you've already drawn your conclusion or not, but we are looking for where the amount of water in the tank is greatest. And so we're going to be looking for a very specific sign change pattern, right? What are we looking for as far as being able to justify that at this particular time the amount is greatest?
A prime t.
A prime does what?
It goes from positive to negative.
Positive to negative. Okay, so there's a number of ways to do this. Why don't you guys take a second, take a minute here, see if you can figure out exactly where this happens, and we'll work on justifying it and figuring out how we could conclude this question. So if we were going to do like a first derivative test concept here, you might, it's far from necessary, but you might do a little A prime sign chart to kind of help you get organized. I'm going to draw something like that up here. It's, guys, really, honestly, it's hardly necessary to do this. So if you didn't do this, it's no big deal. I really think you could just use your calculator and some stuff off the graph to help you figure this out. But I'm going to go ahead and put the critical numbers on here. I've got 1.617, I've got 3 and 5.076, and this is an A prime sign chart. So did anybody do something like this, or maybe at least you did your test values of the intervals? Okay. So can anybody give us an idea of what you did for the left interval? Like what did you plug in? 1 makes a lot of sense. So A prime of 1 ended up being negative 1,000 and something? Okay, so negative. You'd want to supply the number, and you guys maybe all have your numbers in front of you, so I'm going to let you just go with those. Did you guys agree with that? That's no, you disagree. A prime.
I got negative 165 because I subtracted 250.
Okay, and you did plug in a 1. Okay, so we're basically debating about values here. So let's ballpark
I
it.
know it doesn't matter. It's just all negative. Like
Well, no, I think it does matter because we want to be accurate. So let's just ballpark it really quick.
Yeah, sorry, I accidentally placed my decimal wrong on my paper.
Oh, okay. So 120 something?
100 negative
165?
double.
Not this, it was this. Yeah, okay, good. Or that. Yeah, there we go. All right, so negative being the most important thing, but you do want to be accurate, so your point is well taken. How about right here on this interval? Did you guys plug in a 2? Okay, so A prime of 2. Those of you that plugged in a 2, Hannah, what'd you get?
I just looked at the graph that's on it.
We'll talk about that in a second, and that's okay. but those that did plug in a 2, what'd you get? 145?
Yeah, 0.1.
We agree on the 145, those that did plug in a 2. 2 makes the most sense. And of course, that means positive. So at this point, can't we eliminate 1.617 from our discussion? Because at 1.617, A prime goes from negative to positive. Therefore, A goes from decreasing to increasing. Therefore, that's a minimum, isn't it? That's a relative minimum, which could not possibly be the maximum. Right now, it's looking like 3 is pretty good, right? Because to the left of 3, A prime is positive, and if to the right, A prime is negative, that's going to be our most likely candidate. So, did you guys plug in maybe a 4 over here? 4? Yeah? Negative what?
1,000.
You guys agree? Negative. Those of you that did this?
No, never mind, it's 2,000. My math.
546.
I got negative 5.
546.
Negative 546?
Yeah.
Okay, fair enough. I'm just taking positives, negatives here. You guys are all pretty darn good at the calculator, so I'm assuming, unless you're having a bad day, you can do it. Okay? So that looks like that must be it, right? Double check, though. Let's make sure we know what's going on this right interval. Anybody plug in a 6 out there? And did you get a positive?
297.
Positive 297. Okay, fair enough. So now looking at this sign chart, we can now draw our conclusion. So I'm going to say something along the lines of A of t is maximized at t equals 3 because we already have our critical numbers listed above, because A prime changes from pos to neg there, or then, something like that. Okay, so let's talk a little bit about what Hannah said. Hannah basically said, and maybe others did this too, I looked at the graph, right? I looked at the graph, and that I think is valid here. The graph was supplied for you, and anytime a graph is supplied for you, the calculator's active, you really could use the graph. Could you explain your reasoning? Like what you used to kind of get to your conclusion?
Well, if it's positive, it's if f of x is greater than g of x, it's positive.
Be careful with the word it. So she just said if f of x is bigger than g of x, or f of t bigger than g of t, then
A of t is, or A prime of t.
in our, for our notation, A prime would be positive, wouldn't it?
Yeah.
Yeah, okay.
If g of x is less than, or greater than f of x, then A of t is.
Yeah. So you really could look at this in terms of intervals. Right here, on that interval, wouldn't it be fair to say that the rate leaving is bigger than the rate coming in? So that means that when we transition over to this interval, where the rate coming in is bigger than the rate going out, that makes that 1.6 number a minimum, doesn't it? Rate goes from negative to positive. Well then, of course, at t equals 3, we get the exact opposite happening, where, go a little bit further, I guess, where the yellow section is where the rate coming in is bigger than the rate going out, and then that transitions to the rate coming in being less than the rate going out. So the amount goes from increasing to decreasing, so that's where you'd have a max. Sure, good reasoning. Yes, sir.
Did you use the wording in the question? Like you said that just A of t is maximized at t equals 3, but it asks where the amount of water in the tank is the greatest.
Yeah.
You can just recognize that it wants a maximum and say that it's max.
Say that one more time.
You can just recognize that it's asking for a maximum, and then in your answer, say that it's
So instead of saying greatest, I use the word maximum. They're usually okay with that. I know I would be. I'd say that translation from greatest to max is pretty reasonable.
right.
So, I'd say definitely best practice to use their word to like draw it right back to the question. I think it's a pretty small step to go from greatest to max.
Okay.
Yeah. Well, especially, I would say this, like especially if you wrote this,
Okay.
now it's really clear. Like if you didn't write that, then maybe there's a little gray area to it. You're like, oh, are we talking about the same thing? But if you write that, it's like, okay, this is what we're talking about. So, yeah. Question?
So I wrote down A prime of t changes from positive to negative at t equals 3. Therefore, A of t is greatest at t equals 3. Is that okay?
Yeah, I think Matt would like that even better. I agree. Yeah. I like your graph too. Well done.
Oh, thanks.
Yeah. All right. Cool. All right, let's move on then. Let's take a look at example number 3. And I would say example number 3, let me just turn you loose and try it. I don't know, honestly. There's potentially, I don't know what you're going to see here. If you see kind of the wrong thing, this might turn into a really tricky to navigate kind of a question. If you don't see it the wrong way, it might actually feel relatively easy. Hard to say. But I would like you guys to try this with your table partners and give you a few minutes to do that, and then we'll check it out. Good discussion. Questions for me, questions for each other. So let's try to clear this up, and then I'll let you guys finish. Most of the questions that I got, most of the discussions that I heard, we revolved around this idea right here. We're trying, of course, to maximize. That's not much of a mystery. But then the question was, hey, wait a minute, isn't that F equation, isn't that already a rate? And it is, isn't it? It even calls it, it says the flow rate, F in cars per hour, is that equation right there. V, so we actually have 2 rates going on. We have F and V. They're both rates. The key to understanding how to approach this is looking at what you're trying to find. So don't neglect that. It says, what speed will maximize the flow rate? So we are trying to, maybe to say it in slightly different words, we are trying to maximize the rate, aren't we? We're trying to maximize the flow rate. So let me just give you a generic framework. If you are trying to maximize anything, whatever anything is, whether the anything is an amount or a rate of a rate or whatever it might be, if you're trying to maximize anything, you want to set anything prime equal to 0 /DNE. So even though F is already a rate, they're asking you to maximize it. So whatever they're asking you to maximize, you need to set that thing prime equal to 0 /DNE. So should you be finding F prime here? Yes. And then using that to find critical number candidates and then testing those, et cetera, et cetera. That make sense? Okay, so let me give you a couple minutes to try to finish this one, and then we'll be done. You've got to find F prime because we are trying to maximize F. So you had to use, I don't know, maybe some of you are extremely averse to the quotient rule. I don't think you want to be averse to the quotient rule. You might have maybe done some sort of a product rule, but then you'd have to do a chain rule in it. I think it's easier just to do the quotient rule. So if you did do the quotient rule, you should end up with F prime is equal to, let's see here, low. D high is just 1 minus high. D low is 0.04 V all over the square of what's below 22 plus 0.02 V squared. Okay, so that would be a pretty important step for you to show. Quiz or test, definitely be worth a point or 2, probably 2. We want to know, let's do a quick check. We want to know where F prime is either 0 or doesn't exist. Guys, let's check the DNE. Is there any value of V that would cause this to not exist? There isn't, right? Because even if you thought about negative numbers, wouldn't you just immediately square it? Or it would become positive and multiply by 0.02 and then add it to 22, guaranteeing a positive, not a 0 being the point. So there's no V that would cause this to not exist. So we really only need to be concerned about where does this equal 0? And so what is the only part of a fraction that could make the whole fraction equal 0? The numerator. So I'm going to simplify that numerator a little bit. When I simplify the numerator a little bit, I get 22 minus 0.02 V squared equals 0, just by multiplying and adding some like terms. And then we just do some algebra here. 22 equals 0.02 V squared. You divide, and then you square root, and what do you get? Isn't it like 30-something? Okay, so V equals 33.166. Is that right? Okay, listen up, please. Okay, so that is where F prime is 0. So that is our lone critical number, right? There's only one. And so we are looking to maximize the flow rate. So we're hoping that at that critical number, F prime goes from a positive to a negative, right? So we could test this out. If I was going to test it out, I could do something like F prime of 30 and F prime of 34 or something like that. Did you guys do some test values like that? Do you guys do like 33 and 34? Hello? What did you guys do for test values? No? 30 and 35. So Josiah, since you mentioned that, let's go with yours. Okay, so when you plugged in a 30 into f prime, Josiah, what did you get?
Positive, it's like 0.00125.
0.00125 roughly. And when you plugged in a 35, what'd you get? Some negative value. Okay. We want to be as precise as possible. So I would say this is not what we want. We would want to have an exact value. Since he doesn't have it right in front of him, we'll let that go for the moment. And I guess this kind of went off the screen, didn't it? 0.00125, something like that. Of course, being positive. So did you see the sign change pattern we wanted? Yes, we did. We saw f prime going from a positive to a negative. So we can say something to that effect. F prime changed from positive to negative. At that 33.166, I guess that would be miles per hour, wouldn't it? Therefore, flow rate is maximized at V equals 33.166, as far as your conclusion goes. All right. Question?
This was a quiz question.
Yeah.
Where would the point values be associated?
Sure, good question. So I would say, so if this was, oh, I don't know, if it was calculator active, I don't know that that would make too much of a difference. So I would say something like this. Anytime you've got a fairly complicated product rule or maybe a quotient rule, that often is worth 2 points, right? Because there's a lot of moving parts there. So I would say finding f prime correctly, so like having this on your page, would definitely be worth a 2-point deal. And then what I would probably, to be honest with you, I would probably do this. I would say that if you have the correct f prime equal to 0, that would be worth 2 points. Like the equal 0 would be part of those 2 points, for sure. Once you've done that, I'm going to be looking that you found a critical number, that you're announcing, hey, this is important. Like this is a number I'm going to consider. And then over here, we would go with a point for sure for your concluding statement. But your concluding statement needs to be backed up by some kind of evidence. Since there was no graph supplied, and I guess I haven't made up my mind on the, I guess maybe the calculator would be active, but you'd be able to supply some numbers here for sure. There was no general graph that was given to you. I'd want to see some evidence that f prime really did change from positive to negative. So probably 4 points, I'd say. Hey, before you run out, hang on just a second. I want to let you know exactly what will happen on Tuesday, because I didn't know where we were going to finish today. So please listen up. I got 20 seconds, I'm going to use them. So example number 4, we haven't gotten to yet. So what I'm going to do on the video is I will do example number 4, and so this will just be in your notes. I'll do this one kind of with you, and I'll probably do it in pieces. We'll probably like build it little by little, and then we'll transition into that extra worksheet, which the sub will have for you on Tuesday. Does that make sense? At that point, we should have everything all finished up for 3-7. Okay, awesome. Have a good weekend. See you next week.